Imagine a world where you never have to plug in your electric car again. You just pull into your garage, park, and that's it. It starts charging. That's the huge promise of wireless charging. But there's a pretty big catch. If you don't park perfectly, you might not get much of a charge at all. So how do we fix that? Well, the answer might just lie in a surprisingly simple shape.
I mean, think about it. How often do you actually park perfectly centered in a spot? For wireless charging to become a real thing for all of us, the car has to be lined up just right over a charging pad. And that's not just a minor inconvenience, it's pretty much the biggest roadblock for the technology. So researchers started asking, okay, how can we make this whole system a lot more forgiving?
Now, when everything does line up perfectly, dead center, the system is incredibly efficient. We're talking 95% power transfer. That is almost as good as just plugging in a physical cable. So in a perfect world, this tech is an absolute game changer.
But of course, we don't live in a perfect world. If you're off by just 15 to 20 centimeters, that's about the width of a dinner plate, the efficiency just plummets. It drops to less than 50%. You'd lose more than half the energy just from a slightly sloppy parking job. So what exactly is causing this? It all comes down to something called misalignment.
It's really just the offset. The gap between the charging pad on the ground, that's the transmitter, and the coil on the bottom of your car, the receiver. This could be a simple side-to-side shift or even an angle if you're parked on a bit of a hill. The point is, even a tiny error can cause a massive drop in performance.
So engineers knew this was a problem from the get-go, and their first solution, well, it seemed logical, but it had a fundamental flaw, a real Achilles heel right in its geometry. Turns out, the shape of the coils themselves was the real issue. The first big idea was, instead of one giant coil, let's use a bunch of smaller ones, specifically an array of 7 circular coils. The thinking was, this would create a bigger charging sweet spot, making it way easier to line up your car. But this clever-sounding solution had a major, major flaw.
To figure out where it was failing, researchers looked at 2 key areas. The first path was directly over the center of the coils. That's where the magnetic field should be strongest. The second path, though, was over the spaces between the coils. And this is where the whole design just fell apart. This quote from the study just says it all. When the car's coil ends up in one of those gaps between the round pads, there's just nothing. No magnetic field to transfer power. They found that the efficiency drops to just 1%. That's basically zero. This design literally created dead zones all over the charging area. Okay, so if circles create these dead zones, what shape doesn't? This is where the team had a brilliant idea, a really elegant solution inspired by some simple geometry. Look at this comparison. On the left, you can see the problem with circles. No matter how you arrange them, you always get those little empty gaps in between. But on the right, that's the solution. Hexagons. Just like in a honeycomb, they tessellate. They fit together absolutely perfectly with 0 gaps. This one simple change completely eliminates those dead zones.
So that's a fantastic idea in theory, but does it actually work in the real world? Well, the researchers built both systems, the circular one and the hexagonal one, and put them head-to-head.
First up, the easy test. This is when the car drives right over the center of the coils, the best-case scenario. And as you can see, yeah, both designs did pretty well here. No big surprise. This just gives us a baseline. But now, here's the real test. This is that weak spot, right in between the coils. And just look at that difference. It's night and day. The circular array's efficiency just collapses, like we saw. But the hexagonal array, it maintains a much, much higher level of efficiency. With no gaps, the power transfer stays strong and stable. This is the proof. So how much better is it, really? In that critical area where the old design completely failed, the hexagonal array boosted efficiency by up to 10%. Now, that might not sound like a huge number, but listen, that's the difference between a failed charge and a successful one. It's the difference between a full battery and driving away with nothing.
This is so much more than just a cool science experiment. This simple change in shape has some massive implications for the entire future of electric vehicles. So, for an average driver, for you, this means a system that's way more forgiving. No more stressing about perfect parking. It also means more consistent and reliable charging speeds. And here's a really cool side effect. A more efficient ground pad means you can use a smaller, lighter receiver coil on the car itself. That reduces the car's weight and complexity, which is a huge win for EV designers.
And this quote from the researchers really just hits the nail on the head. They get it. They're designing for real people, not for robots in a lab.
Misalignment is, as they say, unavoidable. So building a system that works despite our human imperfections, that is the real breakthrough here.
And all of this leads to an even bigger, more exciting question. If a simple hexagon can solve the problem for a parked car, what about for a car that's moving? What about dynamic charging, where your car gets power while you're actually driving down the highway? Could this one little shape be the key that unlocks a future where our roads themselves power our journey? Makes you think, doesn't it?